Good morning, students. Myself, Badi Alekhyya, Assistant Professor, Department of Artificial Intelligence and Machine Learning, RMD Engineering College. Today, we are going to discuss about one of the supervised learning algorithm techniques, support vector mission. So, in this video, we are discuss what is support vector missions and what is the importance of using support vector missions under supervised algorithms. So, first of all, we have to know what is support vector mission. It's one of the popular supervised learning algorithm. So it's even used for classification or regression problems. So we are aware of that in supervised learning algorithms we have two categories. One is classification and second one is regression. By using this support vector mission algorithm, we can deal with both classification as well as regression problems. So the main goal of the using the SVM algorithm is to create a best decision line boundary between the separation of data. So for example, if I want to classify the data into two parts by using a best fit line, we have to use support vector missions. So here by using hyperplane concepts, the boundary line which we created to separate between these between the two separate classes, we call that boundary line as hyperplanes. So that hyperplane will decide that will separates that which class will belongs to which category and which class belongs to another category. So in SVM, hyperplane will pose a major roles to separate the data from one class to the another class. Here how to choose SVM chooses the extreme points for classification. That extreme points classification will be decided by a decision boundary line. What we said that the decision boundary line we call it as hyperplane. So what are the points near to that hyperplane, we called it as support vectors. Why we named it as support vector missions now? We consider that the nearest points which are close to the hyperplane, that nearest points close to the hyperplane, we call it as support vectors. That's why we name this algorithm as support vector mission. So if you observe this diagram, you clearly understand what we discussed up to now. So this is one category class and this one is another category class. Imagine that we are going to classify that the diseases present or absent. So if the present is if the disease is present it comes under positive hyperplane. If the disease is not present it comes under negative hyperplane. Just imagine it. So by using this hyperplane, we are going to separate these two classes. So above the horizon, if you having the points, we call it as positive hyperplane. Below the horizon, we are having the points, we call it as negative hyperplane. So if you observe this diagram, so the data points, the extreme points, the data points which are closest to the hyperplane, we call it as support vectors. So if you observe here also, the data points which is close to that hyperplane, we call it as support vectors. So the extreme points which are closest to the hyperplane, we call it as support vectors. So SVM will classify the classes accurately by using a decision boundary line, call it as hyperplane. So that hyperplane only will helpful to filter that the relevant points and irrelevant points belongs to one class or not. So for example, let us discuss this example like in KNN classifier also we are using these examples. We are having a strange cat that has some features of dog. So now we are going to classify that the image of cat or dog, whether it is a cat or dog. So this model is created by using SVM algorithm. So if we already discussed in the previous sessions, for every designing of model in machine learning, first you have to consider the data with a lot of images. For this use case, we have to collect lot of images of cats and dogs. So machine learning model, we have two categories. One is training the data, and after training the data we are going to test that after training that model is working in a proper way or not. So in this example, first I am going to train my model with lot of images of cats and dog, and I am going to find out that my SVM will provide a best will I am providing the test data by using this SVM algorithm technique. So I have to find out that the decision boundary between these two data, cat and dog, and I'm choosing this extreme cases. It's identified by using the test data. It's identified correctly or not. We are going to test by this use case. So if you observe that I am going to train my model, I am going to train my model by using lot of cat images and dog images. After training the data, I am going to push the new data by just passing the image of one among these two images. I am going to pass one images to my prediction. That means this prediction is nothing but I am going to test my data after model training completed. If I am going to train that testing that data, if my model is correctly predicting it is a cat, I am going to the classification will be done in a correct way. So in this way of training we are using SVM. When compared to other classification techniques, the hyperplane decision boundary line helps to classify the data in a accurate manner. For in these examples, dog and cat images, if I am training to the model lot of times, is correctly identifies the extreme points. If it is the points which are closest to that hyper plane, is correctly classifies that it belongs to cat or it belongs to dog. So the results the provided by SVM algorithm is accurate when compared to the other algorithms because of this hyperplane. So we have two types of SVMs, linear SVM and non-linear SVM. So under linear SVM, we are linear set. For example, if you are observing the previous thing, we are going to classify the cat images and dog images. If the straight line, that means is correctly classified, equal number of points are classified at the dog side and equal number of data points classified at the cat side or dog side. The decision boundary line is linear and is linearly separable between the two classes. For the type of SVMs we are using, for the type of classifications we are using linear SVM. That means the straight line is enough to separate the two classes. But when coming to the non-linear SVM, here it's not possible where the scenario is, that means the data points are scattered in the environment at different places. When I am going to applying the technique of hyperplane, so it's the classification will not be done in a straight line, it should not be linear. At that time we are using non-linear SVM. So in real time we are using so many functions. Among that radial basis function is one of the important functions which is used to classify non-linear data points under SVM. That's all students. Just a brief idea regarding what is SVM and what is the definition of SVM and which type of problems will be solved by SVM and what are the important terminologies we have to know before going to implement SVM algorithm, and after that what are the two different what is the use case implementation, how it is going to train and test the data in the SVM algorithm, and after that we discuss that what are the different types of SVM, in which cases we are using linear SVM and which cases we are using non-linear SVM. That's all for the today's session. Just a brief introductions to SVM algorithm. So in the next class I will meet with the new concept. Thank you students.